Hey, good afternoon, everyone. I'd like to thank you all for joining us today in our weekly webinar series. Today our featured topic is Fusion Splicer and Cleaver maintenance. My name is Jessica Petrahoy, and I'm the marketing coordinator at fiberoptic.com. Fiberoptic.com is a leading provider of fiber optic products, training, and rental equipment. We're pleased to present this topic to you today. With us today to talk about Fusion Splicer and Cleaver maintenance is Rob Harlow. Bob is a production assistant and customer service agent for Precision Rated Optics with over 15 years in the telecommunications industry. Bob will be reviewing splice verification, cleaning your splicer, replacing electrodes, cleaver blade rotation, and more. When Bob is finished, we'll take questions from the GoToWebinar question box at the bottom of the screen for a question and answer session. Remember that our webinars are recorded and available to you online at fiberoptic.com/webinar. Thank you again for joining us today, and at this time I turn the presentation over to Bob.
I want to thank everybody for joining the webinar. Today's agenda, we will be going over Fusion Splicer maintenance, splice evaluation, cleaning, electrode replacement, arc calibration / arc test, cleaver maintenance, cleaver evaluation, cleaning, blade rotation, blade height adjustment. Splicer maintenance. First off, let's get familiar with some terminology. The bottom left, you'll notice fiber alignment guides, or sleds, some people call them. In the middle, we have fiber illumination LED, and to the right, motor-operated sleds. Additional, we have magnetic latches, primary fiber retention cleat, or straight up fiber holder, and retention pad. It's basically the rubber pad that's in the middle of the fiber holder, which allows the fiber to be moved in without sliding back and forth. And you have the CCD cameras for fiber viewing. These are very important to keep clean because this is what gives you your image bouncing off the mirrors that are underneath the hood. And the all-important electrodes. Fiber is manually inserted into the splice bed area. This area is located between the center apex of the electrode and the outside edge of the V-groove. Use caution. Do not contact the end face of the fiber to the V-groove, then flip down the retention cleat. In other words, when you're ready to set that fiber down, do not hit the blue V-groove because you can chip the end of your fiber. And also remember to put on heat shrinks before you do any splicing. If you don't, you will have to break and redo it. This is all time. So we have splice evaluation. Good splices. Up at the right you'll see a white line, sometimes a blurred thin line, an offset, diameter difference, dirt on fiber. Visually inspect splice after the program has run using both X and Y views. Some flaws that do not affect optical transmission are acceptable as shown. Some fiber, e.g. fluorine doped or titanium coated, may cause white or black lines in splice regions that are not faults. Bad splices. Some flaws are unacceptable and require starting the splice process over. Some, like black spots or lines, can be improved by repeating the arc step, but never more than twice. For large core offset bubbles or bulging splices, always redo. You'll know when you do the splice if you have to redo it just by looking at it. And remember that all your splices, the result is an estimate. It's not the true result. That you need an OTDR. Common splice problems: bubble or inclusion, contaminated fiber on end face, a poor cleave, fusion current too high, pre-fusion current or time too low. All those settings are in the menu of the splicer, that whichever splicer, if it's an 810 that we're showing you on this webinar. Enlargement, which means an auto feed is too fast or the current is incorrect. Not fused through at all, which means you'll basically, the fusion current's too low, pre-fusion time is too short. You'll know immediately when you lift the hood, the wind hood, the fiber will not be spliced together. Constrictions: contaminated electrodes, pre-fusion current too high, pre-fusion time too long, current too high, feed rate too slow, gap too wide. And again, all these settings are in the menu of a splicer. Match heads. Again, contaminated electrodes. Fusion current much too high, pre-fusion time much too long, pre-fusion current much too high, auto feed too small, and the gap is too large. Splicer cleaning. Cleaning V-grooves and bare fiber pads. This is very important that when you are splicing that you keep these areas especially clean. V-grooves are a precision guide that keeps the bare fiber aligned for splicing. Bare fiber clamps hold the fiber seated into the V-groove. Tiny bits of dirt or coating residue in the grooves or on the pads of the clamp can cause the fiber diameters to be offset and will create poor splices. The procedure requires pure isopropylene alcohol, 99% pure or better, V-groove cleaning brush, Titan woven lint-free cotton swabs. Must emphasize this: do not at any time use canned air on cleaning your electrodes. That will contaminate them. Cleaning V-grooves and bare fiber pads. Procedure: 1. Moisten the V-groove cleaning brush with alcohol and brush the V-grooves outward, away from the electrodes, to prevent dust falling on the microscope lenses. Use firm pressure to clean the bare fiber pads with a cotton moist alcohol swab. Go over the same area with a dry cotton swab to remove any excess alcohol. Cleaning the LED mirror covers, very important, along with cleaning the other parts of the splicer. This is what gives the image into the lenses that are underneath it. So you always want to make sure and inspect them thoroughly after each use. And with that, you will use 99% isopropylene alcohol again, and lint-free cotton swabs. Moisten a cotton swab with the pure alcohol. Gently wipe the mirror surface. Use a dry cotton swab to wipe off any excess alcohol. The procedure requires, for cleaning the lenses, again, using 99% isopropylene alcohol and cotton swabs. There are 2 microscopes between the V-grooves in the fusion splicer stage area for viewing the fiber to be spliced. Large dirt particles on the microscope lenses can reduce the ability to inspect fiber and will yield inaccurate results. Cleaning the microscope lenses procedure. Turn off the splicer. Open the hood covering the splice area. Remove the front and rear electrodes to expose the lens surfaces. Each lens lies between the electrodes at a 45-degree angle. Gently clean each lens with a cotton swab, moistened with a small amount of alcohol. Then, in a spiral motion from the center of the lens and work out to the edge. Wipe each lens again with a clean, dry cotton swab to dry the alcohol, thus avoiding spots. This is very important. Electrode replacing. Electrodes will typically need replacing after approximately 2,000 discharges. Your splicer will have a count number. The Fusion Splicer maintains a count of the number of arcs discharged. This procedure includes instructions about resetting the counter to 0 after replacing the electrodes and conditioning the tips. Sometimes it's important to document, how many splices you have done at any project or at the end of the day after using them. Removing old electrodes. Very important. Turn off the Fusion Splicer and unplug the power cord. Using your fingers, loosen the thumb screw to remove the electrode cover plates. Remove the old electrodes and discard. Note, while the electrodes are out of the unit, carefully check for dirt on the microscope lenses. Then handle the electrodes. Avoid touching the metal portion with your skin. Your skin has oil, and that will affect the electrodes. If touched, clean the electrodes with alcohol and gauze. Electrode cover plate thumb screws. Installing new ones. This is very important. When you're installing new ones, before installing new electrodes, gently clean the electrodes with pure alcohol and gauze wipes. Hold the electrode by the plastic button. Place the electrodes in the retaining groove. When replacing the electrode cover plates, push the plastic button against the clamp wall to place the electrode tip at the correct distance. Ensure the beveled edges on the electrode cover plate are facing inward towards each other. Gently tighten the retaining thumb screw. Do not over tighten. Replacing electrodes. After changing the electrodes, reset arc count, perform conditioning arc or stabilization, and then you will be running a arc calibration. This will have to be done numerous times until the splicer is acclimated in where you're working. If you're outside and it's cold, it may take a little longer. If you're inside and there's a lot of dirt, that can cause more arc calibrations to have to be done. Because remember, everywhere you go, if you go from outside to inside, that machine has to be acclimated. So if you're outside and it's cold, and you come inside and it's at a comfortable temperature, you have to do an arc calibration until that machine is acclimated in the conditions that it's working in and you are working in. When should we do an arc calibration or arc test? this is very important, changing fiber types. So if you're going from, non-dispersion to single mode, it's recommended that you do an arc calibration, arc test. Changing splice locations, like I said, from outside to inside to the back of a van or truck that's capable of splicing inside. Extreme temperature changes, humidity, poor splice performance, worn or dirty electrodes after electrode replacement. In where I'm working, it's a controlled environment. When I clean and calibrate any of the splicers that we have, I always do an arc test which calibrates the machine. But I do this all the time. It's a very good habit to get into. It may take some time, but it's important because in the end, your splices are going to be good. What is the arc calibration / arc test? The Fusion Splicer has a built-in arc test feature that should be used to ensure constant high-quality splices. Performing an arc test automatically adjusts the arc power level for the splicing program selected and will center the fiber end faces relative to the arc heat zone. The adjusted arc conditions are retained when the splicer is turned off. Now we're on Cleaver maintenance. On the left side, you will see, with the big X through, you will see 3 pour cleaves. The top one, you'll see an angle. The middle one is a chip up at the top, and then another one would be a break. The one to your right, bottom right, is the correct. It should be an almost perfect 90-degree angle when you're looking at it in the viewing area of the splicer. Very important areas to clean on the cleaver. First thing, the fiber grooves. A lot of times cladding and chunks of where you're working and little pieces of fiber can get stuck in these grooves. You can take a small piece of fiber and just slide it through, uncleaved mind you, slide it through to clear out anything. You can use a cotton swab. That will help also. The blade edge, before and after using, it's very important that you clean that because debris can be caught up on that too. In the anvil, the part that comes down that ensures the whole piece of fiber does not move when it's being cleaned. The cleaver should be, like I said, the cleaver should be cleaned before and after each use of the workday, because this is basically this is what gives you the ability for your splicer to work properly. Without a good cleaver, your day is going to be really long. So you want to make sure that the cleaver is always working properly. And when you got a good cleave, your machine is going to pick up the degree of that cleave. And if it's 3.0 or higher, depending on what machine you have, it will automatically kick it and you will not be able to cleave at all, or splice at all. Dust on the blade's edge will diminish cleaver performance. So very important, you just take the time, take a nice cotton swab and clean the top of the blade using 99% isopropylene alcohol. Pay attention to remove any fiber shards from the top pads. This will cause poor quality cleaves.
So when I'm cleaving, I want to make especially sure that this pad and this pad are clean, because as the cleaver blade moves under, if these pads are not clean, fiber itself can move, and I'll get an angled cleave rather than a straight cleave.
Rotating the blade. This is very important too. Maintaining a good cleaver. You'll notice the two blades at the bottom, they are numbered. One is numbered from 1 to 16 and one is numbered from 1 to 12. The cleaver blade should be rotated after approximately 1,000 cleaves. This is something also too you want to keep in mind. The amount of cleaves that you do with the cleaver that you have, and keeping this in mind, it's very important that you kind of know how many you have done, because you want to keep with the maintenance, making sure that each number has almost the right amount of cleaves on it. 1,000, 1,500 is way too much. You need to adjust that cleave. Dull blades will often leave a lip or display cracks in the cleave. When this begins to occur, rotate the blade according to the manufacturer's procedure. Obviously, you start at 1, and then after 1,000, you go to 2, and so on. Typical procedure, rotating the blade. You'll see it loosen the blade center set screw. Rotate the blade 2 positions using a cotton swab. Do not touch the blade with bare hands. Do not rotate with metallic tweezers. Blade is typically rotated towards the front of the cleaver. Tighten the blade set screw. Do not over tighten. This could cause wear on the screw or stripping it. Test cleave and view in Splicer. That's the only way you're going to be able to tell. Once you've cleaved a piece of fiber, you lay it into the splicer, close the lid, and if it's on automatic, it's going to bring the two fibers together. And if it's a good cleave, if it's on automatic, it will automatically splice it together. If not, the splicer won't allow you to go any further, and you will have to re-cleave. Blade height adjustment. After the blade has been rotated thoroughly, all positions, the blade height must be raised. The blade can then be rotated as needed through another series of positions. The height can be adjusted twice to give a total of 3 full series of blade rotations. That means every time you adjust it, you have to adjust the height. Blade height adjustment. Typical procedure. Loosen the locking screw for blade height. Rotate the blade height adjustment screw. Turning in a clockwise direction typically raises the blade height. Do not over adjust. Tighten the locking screw for blade height. Do not over tighten. This may damage the blade. When to replace. When the blade has made 3 complete series of rotations at all 3 blade heights positions, the blade must be replaced. If the blade is damaged due to over tightening of the set screw, of improper handling, the blade will be replaced, need to be replaced. Typical procedure. Unscrew and remove the blade set screw. Remove the blade with tweezers. Insert a new blade with the one position at the top. Use care. Do not damage the blade during replacement. Do not touch the blade with bare hands. Use gloves. Replace and tighten the set screw while holding the blade in place. Do not over tighten. Adjust blade height to the lowest setting. So this comes to the question and answer part of the webinar. If there are any questions now would be the time to ask them. So I see that there's no questions. So again, I would like to thank you for attending this webinar on Splicer maintenance and Cleaver maintenance. All our webinars will be available online at fiberoptic.com/webinar.